All right, so we're group 6, and here's our final presentation. All right, so taking a look at the data set that we chose to analyze, we chose to take a look at airport traffic that was being impacted by COVID and how that kind of trended during the pandemic. In terms of the actual data that was included within the data set, we had daily traffic levels for airports around the world in countries like the United States, Canada, Chile, and Australia. We had 28 different airports, and despite the fact that it was a global data set, though, the data was pretty heavily skewed to the United States and Canada, though, as 26 of the 28 airports were located within North America. So while this was a global data set, most of the data was focused on traffic at airports in North America. And the most important measure that was included within the data set was the traffic as a percentage of baseline. So this data measured airport traffic relative to average levels of traffic from February 1st, 2020 to March 15th, 2020. So the data was basically taking a look at traffic during COVID and how that compared to pre-COVID levels at the airports. And then taking a closer look at each of the variables that were provided within the data set. There was the variable for aggregation method. All data was collected daily, the date that the data was collected, the airport that the data was collected at, and then percentage of baseline. As I mentioned, this was the most important variable, shown as a percentage of traffic at pre-COVID levels. The data set also included latitude and longitude points that we had to break out on our own for the location of the airports. And then the data also included the city, state, and country that each of the airports is located in.
So here are some of the challenges we encountered when analyzing the data. The first one was the airport locations were provided as a century coordinate, and it had to be converted to separate latitude and longitude. And the second one was the dates provided did not have the day of the week, so it needed to be converted into the day of week in order to perform some of the analysis that we have. And lastly, some of the dates provided, such as August 17th, there were no airport data for those points.
All right, now taking a look at one of the visualizations we made. This is a symbol map where each airport shown on the map, and the color is the traffic as a percentage of baseline. We chose to use a diverging color set here with orange and blue, as those are CBD friendly, and also as those show blue locations are above the midpoint in terms of the data range provided, and the orange points are below. And then taking a look at a few of the interactive features. Actually, if we take a look at the actual tableau, there's an interactive filter on the top right where the user is allowed to select the month they're looking to take a look at, so they can choose one of those, and then that automatically changes the map to show the first of the month for that day, and the visualization changes to reflect that. And then additionally, we also built in a interactive tooltip feature where once a user hovers over a specific airport that they're interested in, you can then see how traffic as a percentage of baseline has changed throughout the month, in case you're interested in taking like a deeper look at individual airports over that time period. Additionally, in this visualization, we also built in the pages feature. So if you click the play button on the right-hand side, it actually runs through each day of the month, and the title changes as well, showing the baseline traffic at each day, allowing the user to get a better feel for how all of North America has kind of trended during different time periods, and seeing how different airports compare to each other within the United States as well.
So moving on, this is a line chart that shows the trend of percentage of baseline for different countries in 2020. And we use 4 different colors to represent the 4 countries that we are analyzing: Australia, Canada, Chile, and the US. The color legend is placed at the right of the chart as a reference, and the axis shows the months. Within 2020, the y-axis is the average percentage of baseline range from 0 to 90. Looking at this trend, we can see how each country changes throughout 2020 and predict this country's future performance if needed. All 4 countries experienced a rapid decline in April, and the percentage of baseline for Australia is the only one among the 4 that keeps decreasing throughout the year.
So this is a highlight table showing the monthly airport traffic as a percentage of baseline for each country's airport from March to October. We chose a diversion color scheme with orange and blue, so the audience can easily identify the airports with the higher monthly average traffic, as indicated by blue, and the airports with the lower average monthly traffic, as indicated by the orange. A more neutral color will suggest to audience that it falls somewhere in between, so we have like moderate traffic. And the orange and blue were also CBD friendly. That was also why it was chosen. The colored legend on the right will serve as a reference for the range of average percentage of baseline across a color scheme. The title of the table was average traffic for each airport in 2020 will give the audience more context into what the data is representing. And it's organized, the airports are organized by the countries to allow easy comparison between the specific airport and a particular month. And there were just a few interesting things if you take a quick glance. One thing would be that there was a sustained lack of traffic in airports like Kings Ford Smith Airport and San Diego International Airport.
And then taking a look at our next visualization, we made a vertical bar chart showing daily traffic and a 7-day moving average overlaid on it. And this chart specifically is kind of meant to pair with the previous highlight table. So if you found a specific airport interesting, taking a look at the trends on a monthly basis, a user can then dive a little deeper in to see how the daily airport's been trending in terms of individual days and also on a weekly trend. And taking a look at this visualization in Tableau for a quick second, this one also has an interactive feature through the filter where a user can select any airport they're interested in and take a more specific look and kind of see how it's been trending and compare it to other airports regionally in other different countries and things like that, allowing the user to kind of seek more information if they're looking for it.
So when we first looked at the data, we were curious as to how the recovery trend was for all airports on an average. Thus, since the pandemic hit, we decided to create a line graph with time on the x-axis against the average percentage of the baseline on the y-axis. We also added color to the average percentage of baseline to make apparent the peaks and the troughs. Upon creating the chart, we observed that the line graph had consistent and wavy pattern all across. To understand why this was happening, we hovered over the peaks and the troughs to find out why it was periodic. And it happened approximately at the interval of 7 days. Hence, it led us to find out more about how air traffic was affected by a particular day of the week. As mentioned above, we initially did not have days of the week in our data, but after adding the days manually, we created a highlight table with the days across the months and chose the average percentage of baseline by a diverging color scheme, as we did with our other graphs as well. The blue color represents the higher recovery rates, and the warmer colors, such as the oranges and the reds, represent lower recovery rates. This table was particularly interesting because it was very apparent that people travel less on the weekends than on weekdays. To feature interactivity for this chart, we had given the option to filter by country. For example, the table above is for all airports in Canada.
For summary, we found that the COVID impacted global airport traffic a lot, and each country experienced a decline in traffic as a result of that. Most countries at this point are moving into a recovery stage with traffic pushing closer to baseline levels, but some countries like Australia are actually keep declining in traffic recently. We can also see that while airports or experience traffic declines, each one of them responded and recovered very differently. Some locations had massive sustained drops in traffic over long periods, while other locations bounced back to semi-normal levels within a few weeks. Our analysis also found that weekend travel was hit particularly hard by COVID, as traffic was down significantly relative to baseline. Weekday travel was the most stable throughout the past few months and has begun strengthening in some countries like Canada. Even now, weekend traffic countries to be the most volatile and impacted the most by COVID.
As for future steps and next steps, our current data has only limited us to 2 airports outside of the North American region, one in Chile and one in Australia. If we were to take this analysis further, we would research and gather more airport data outside of this region. Comparing the average recovery rates among countries that just had one airport seem a bit deceptive. In addition to getting recovery data from airports from more countries, it would have been better to also get insightful data like the actual number of flights taking off from each airport. Having that data would tell a better story regarding how busy each airport actually is compared to others. Thank you so much.